Hello, it's me, Hollow Flaherty, and now we're going to do a demonstration of generating a Solidworks model, in this case for a Rhombi cube octahedron calculator, but it can be applied to any generic shape for your space module. First thing we need to do is get the dimensions of the side of the Rhombi cube octahedron. By putting in the volume here, I use the Rechner Online calculators, because they have the best variety and accuracy of calculation. So if I put in my volume for my space module here, 0.066 meters cubed, and press calculate, get an edge length of 0.196. That should do fine. And also, the other thing I'll need will be the dihedral angle for a Rhombi cube octahedron as well. I put in Rhombi cube octahedron dihedral angle in Google, and it gives me two dihedral angles. There's dihedral angles between the triangles on the shape and between the squares. I want the one on the squares, which is 135 degrees, or 90 plus 45 degrees. So 135 degrees is what I want there. So if I open up the Azure virtual desktop, so I'm going to access this all remotely. I get access to the newest version of SolidWorks there with all the components that I need. So if I click on SolidWorks here and wait a few minutes for that to start up. So when it opens, if you go into File, New, or I may just show you this menu automatically, you can just select Part there. Okay, that. This will take considerable time to open up. So once it's opened, the way we work in SolidWorks is we create two-dimensional objects on flat planes and then do things like extrude or revolve these into 3D shapes in order to create 3D solids. We're going to create a 3D Rhombi cube octahedron solid, and we're going to start with creating a single face on a horizontal plane. So I'm going to choose the top plane. So I choose top plane there, and I want to put an object called a sketch on that. And that sketch is going to be a square. So if I select a center rectangle there, now I'm looking straight down on the top plane there. The center of my rectangle is going to be on the origin of this plane here. And I'm creating a rectangle, but I can set the sides. Important thing to set here, if you see IPS down in the bottom right, we want to set that to mmgs, millimeters, grams, and seconds. We want to change that to metric units, not quite SI, which would be meters, kilograms, and seconds. But since we deal in millimeters in technical drawing, we're going to stick with that, with millimeters. So if I click on this side here and click on the sketch in the outline menu on the left and click Edit Sketch on that, I can start adjusting this. So I click on this face here, it gives me its length and its angle. So I want it to be 196 millimeters, or 0.196 meters, and an angle of 0 is fine. That gives me the correct width. And if I do this one here, I also want this to be 196. Now if I click here, it'll zoom to fit. I have my shape there. Out of this, I want to create a surface, a solid surface. So I go to Insert, Surface, or actually first, I click this to create the sketch. Click on the sketch and go Insert, Surface, Planar. And it simply creates a flat surface out of that square there. I also want to create a window on this. That way I'll have lots of windows in my space module. So if I go back to the top plane here and go another center rectangle and select the same origin, I'm going to draw another square. arbitrary size. I'm going to set the size in a while. If I click escape here and click on the side, I can set the side now. I'm going to set that at 75, give me a nice round figure. Set this one as 75 as well. And that's going to be my window in the, I click there. So now if I take sketch 2 and click on features and curves, split line. So I'm going to use this line to split this surface into two. That's my, so my selection is sketch 2 there, and the small square. And if I select this, it's going to split that face 1 there. It's going to divide it up into 2 parts. Can't really see that, but there are no separate entities there. So now I'm going to try and extend this flat surface into a 3-dimensional entity. So if I go up here and I want to select an isometric view, give me more of a 3-dimensional view, and zoom out on that by scrolling. What I'm going to do next is take this surface here and flip it up through 135 degrees, the dihedral angle, so I get a second face on my solid. So if I go to analysis preparation and move copy bodies, it gives me options to translate, to move, or to rotate objects. So if I click on my object there, it's called split line 1, and I want to copy it here. I want to create a copy of it, and I also want to rotate it. And if I select the edge I want to rotate around this one, I'll get, I have to put in an angle as well, which is 135 degrees. 135. It will default to degrees. And you'll see it's giving me a preview of what it's going to do. It's going to flip that up to 135 degrees there, so I can accept that. Click there. I have my new face here now. And next what I'm going to do is going to take that copied one, flip that around this edge here in the same way. So once again, analysis preparation, move copy bodies. Select my object. And I want to rotate. Select the edge I want to rotate around. You might need to zoom in on the edge in order to select it. 135 degrees. That's actually slipped it around in this direction. We want to slip it around in this direction, so I put in minus 135 degrees. And there we have it. Might have to do that once or twice during generating it. And we keep doing that. So if I take this face, flip it around this edge. Move copy, select the face, and zoom in to the edge, 135 degrees. And just check that that's in the right orientation. And one more time here. I'll select my entity and rotate, select the edge, 135 degrees. That's flipped it the wrong direction, so I put in minus 135 degrees. And that will give me my top face. You can see it's starting to form here. And so as you can see from the shape of a rhombic cube octahedron, it's wider around the middle. There's actually 8 faces around the middle, and there's 4 of these squares around this plane here. So what I'm going to do is to create an additional face by flipping out this one here. So if I go to move copy bodies again, and select this one around the middle, and select the edge I want to rotate it around. Once again, same angle, 135. I'll just reorient that so I can make sure it's the right orientation. It is. So now the advantageous thing about polyhedra is that they are uniform or repetitive structures. So, and they're also symmetric around a lot of axes. So if I create a axis of rotation through the center of this face and this face, then I can rotate these parts, these middle ones, around that and create copies. In order to create this axis, I want to go to Insert, Reference Geometry, and Axis, which I'm going to create from the intersection of two planes. So I can select those planes here by opening up this menu. If I click on the two vertical planes, the front plane and the right plane, that will create an axis, that yellow line there between them, and I create that. Now I can rotate it around this axis here. Next, what I'm going to do is go to Insert, Pattern / Mirror, Circular Pattern. And so I want to select this, and this face as my features. I want to create bodies out of these, so I select bodies here. I need to select my direction 1 as axis 1 there. It's already selected by default, or may not be. So now I just need to select these faces here. And I also need to specify how many of them. So I want to create 4 of them, but I want them to be 90 degrees apart. And if you see that there, then has now almost completed the solid there, or a shell for it anyway. And what I also need to do is then fill in these triangular faces here. So if I set this up correctly with correct dimensions, then I just need to create sketches on these planes where these triangles are, and then create faces on them. I need to create a plane, say in here, in this triangle. So if I go to Insert, Reference Geometry, and Plane, I can create a plane out of a line and a point. So if I create one edge of this here, also select this point down here, I have a plane here. Select that. Next, I want to create the triangle on that plane. So if I go to select plane 2 and sketch, and I want to create a line on that, reorient it so I can see my plane. And I select the vertices of the triangle as the endpoints of my lines. Back up to the starting point. Should have a close sketch, press escape to stop that, and click this into the up here to create that sketch. So I have sketch 4 there. I want to turn that into a plane. Insert, Surface, Planar. And tick to create that. Now I've filled in that edge there. And next I'm going to do the same around with this one here. Create a plane through here and create the triangle. So if I go to Insert, Reference Geometry, Plane, and select a line and the other vertex, I have my plane there, and create the triangle there. So if I select that plane 3, sketch and line, bring it back into view, and select the vertices of my triangle. And escape, then we'll stop that and click this to create it. Have my sketch 5 there, which is the triangle. I go insert, surface, planar to create a triangular face out of that, and tick to create that. Now, the next step is to take these two entities here, rotate them around the same axis, create 4 copies, or create 4 in total. So if I go to insert, pattern mirror, circular pattern, and I want to create bodies, select the 2 triangular faces, and I want to create 4 of them 90 degrees apart. I need to select my axis as well. That, and I should have a solidified body there. It's still hollow, so I'm going to do a file, save there. What I'm going to do is create a solid out of this. So I'm going to call this Rhombi underscore solid. Save that. So while we're going to be creating a hollow object, for the CFD analysis of this, we're going to be modeling, it's only the air inside that we're going to be modeling. So we need to create it as a solid, the solid representing the air inside. And we're going to look at heat transfer through the air. So we need to turn this now hollow body into a solid. Once that's finished saving, what we're going to do is take all these faces, knit them into a solid. So if I go to insert, surface, and down at the bottom here, we say knit. Need to select all these solid bodies here. So I throw so I select all them and then click create solid as well. I'll see if that works now. It's created something. If I take a slice through that, you can see it's solid now, which is what I want. I can turn off that. The next thing I want to do is create a spherical cutout near the bottom of this to represent the bulb. So where you put in the bulb through the bottom, and that heats up the space. So I'm going to create a spherical cutout of a diameter 60 millimeters. Bulb is approximately, generic bulb is approximately 100 millimeters high. So top of the bulb is going to be 100 millimeters off the base of this base here. And then, so the center of that sphere is going to be 70 millimeters up. I'm going to create then on the right plane. So if I zoom in on that, so near the bottom there, I'm going to create a construction line from the bottom up to 70 millimeters. So I've selected right plane, line, and I do an arbitrary line up from there. I want it to be, escape out of that, select the line, set it to 70 millimeters. It's also for construction, and take that, and now have my construction line. This point here is going to be the center of my my sphere. If I don't create a circle out of that, what I do is create a semicircle and then join the edges of that with a straight line, so you get a sort of a wedge shape, like a wedge out of an orange. Then I'm going to revolve that around its center to cut out a hollow out of the middle of the solid. So I'm still on sketch 6 here. If I click on center point arc and select the end of this line as my center. I want an approximate radius of 30. I'm going to set that in a second and spin that around to get an arc of 180 degrees. It's at 28.2 there. I can change that to 30. It'll expand it. Then I join up the two ends of that with another line. A solid line this time. So select the two ends. And escape. And create that. And click here to create the sketch. So if I look at my sketch there, it's kind of a wedge, orange wedge sort of shape. I'm going to now take that sketch, revolve that around this axis, cut out a spherical cutout in the solid. So I click on Sketch 6 and Features and Revolved Cut. I need to select an axis. So any of these vertical lines will be fine. And 360 degrees, fine. That now, you don't see anything initially, but if we take the cross section then and bring that around, you see we have our cutout there. It's going to represent our bulb. We're going to put a heat flow of 100 watts through that when we get into the CFD software. So our model now is suitable for use with the CFD software. So we're going to save that. And we'll come back in a few minutes to show you how to finish that off so you can have a model that's more similar to the one you're going to build and get dimensions from that. As it stands there, then you have it ready to do the CFD analysis on it. Now I want to convert it into a form that's suitable for getting design drawings. So it's going to reflect more what we're actually going to be creating. But I want to turn it from a solid into a hollow shell now at this stage. So once again, I'm going to go to File, Save As. I'm going to give it a different name. So instead of Rhombi Solid, I'm going to call it Rhombi Hollow. Save that. And next thing we're going to do is turn this solid into a shell to make it hollow. So if I first remove the cut revolve, so I've saved it here, so it's not going to we're not going to lose anything. And then click on Surface Net 1, that shell there. I set my parameter here to 6 millimeters because that's the thickness of my cardboard. Select Shell Outward. Click that and you'll see it's now just shell with that thickness of 6 millimeters. Next, I'm going to give you a rough overview of the how to produce some design drawings from this Solidworks file. There's a lot more detail of what you need to produce in John's video, detailed design drawings on the bright space. So this is just a quick look at it. So if I go to File, New, if I save this, save that, go to File, New, and select Drawings, okay? It asks you for standard sheet size, select A3 ISO. Might take a few minutes to start up. And if we go into here and select Browse, give you a list of the models that you've made. We want the Rhombi Hollow one. And select Open. Now you'll see it'll create this square here, so somewhere around this point here. I'm going to put it in. This is going to be my elevation of my set of drawings. I click that in there, and automatically it'll allow you to create a projection of that. So I'm going to put a side view beside that. As you can see, the end view, side view, is it's pretty much identical because it's a regular polyhedron. With uniform windows on it, so we're not gaining a lot really from that. What might be good to see, though, is a projected view. So if we take a view, project it at an angle there, like that, you can see it gets more interesting detail on that now. Okay. As you can see, we're not seeing an awful lot from either the plan or the view below, So I'm going to leave that out. If I press escape then, we have our 3 views there. You can see it's not really filling the sheet either, so I'm going to go over this menu on the left, click use custom scale. Instead of 1 to 10, I'm going to go 1 to 5 and then reorganize the drawings a bit so that they fit in nicely. So if I click on this, bring it over a bit. I want to make maximum use of the space and take this projection here and move that over. So this is our elevation in view and our projected view there. I'm going to do a few things with this now. If you click on the elevation there, you can see it says display style here. Change that so it shows hidden detail, and you can see the inside of the line, so you can see the thickness of the cardboard there. If I click on the projected view, might be nice to show that in 3 dimensions, or this is a bit more 3-dimensional, so you can show the surfaces rendered as a result of that. Okay, I'm happy enough with that. And we click here. Next, we want to put some dimensions on it. So if we're going to get this built, we're going to need to have dimensions on it. So if I click on Smart Dimension, and I want to give the length of this side here. Okay, that's coming out as 7.91, so something's wrong with that. We said it was around 200. Go down to the bottom right. It's in inches, pounds, and seconds. I'm going to change it to millimeters, grams, and seconds. Remember, we originally set our length to 196, but it's been projected out, so it's over 200 now due to the projection outwards. Useful dimension will be the height. Now click Smart Dimensions again. And click on the top here and on the bottom. And it will give us our total height of 485, millimeters. Maybe the dimensions of the windows will be useful as well. There's 75. And might show the height of this section here, because it's at a slant. So I'll try and select this vertex here as well and bring that out. Copy that with this height here, try and get them in a line. So we have most of the detail that we need. We can infer from most of this that it's a regular shape and that it's most of the dimensions are the same. And so that's the bare bones of some design drawings from this. Probably need more dimensions. There's more detail included in John's detailed design drawings video. Remember to click on Save up the top and call it something like Rhombi Drawings. And we save that. So include something like that in with your report at the end as well. Show the dimensions of your design.